Lesson 11, Operational Amplifier, Applications. Section 11.1. Inverting Amplifier. This is a circuit of an operational amplifier. This chapter will show how to use this very high-gain amplifier. The gate electrodes of TR1 and TR2 are the input terminals of this amplifier. They are denoted by V in minus and V in plus respectively. Then, DC voltage sources are connected to the positive V line and negative V line. The line, that connects the two batteries, is connected to the ground. This operational amplifier is depicted by this symbol. Experiment 11.1. Pause the video and follow the instructions. Measure V1 and V2. Then, find the voltage gain AV. These are the results. The blue line represents the waveform of V1. Its effective value was 135 millivolts. The red and green lines represent V2 in the cases where R2 was 10 kiloohms and 1 kiloohms respectively. Their effective values were 1.34 volts and 139 millivolts. Because the polarity of the output voltage V2 is inverted from that of the input voltage V1, this amplifier is called an inverting amplifier. When R1 was 1 kiloohms, and R2 was 10 kiloohms, the voltage gain AV was 9.93. This gain was approximately equal to the ratio R2 over R1, that was 10. In the case where R1 was 1 kiloohms, and R2 was 1 kiloohms, the voltage gain AV was 1.03. This gain also coincided with the ratio R2 over R1, that was 1. These are, from left to right, the appearance, 3D drawing, and pin layout of an operational amplifier integrated circuit, op-amp IC for short. The model number is TL082CP. The pins are numbered counterclockwise around the IC, starting near the notch or dot. This IC contains two operational amplifiers. The eighth pin is the terminal that receives the positive DC voltage, and the fourth pin is where the IC is supplied with negative DC voltage. These are the connections for testing the inverting amplifier. The ADALM2000 can supply positive and negative DC voltages from the V plus pin and V minus pin respectively. This is a 3D drawing of the connections. Pause the video and check your wiring. This is the equivalent circuit of an operational amplifier. VI is the differential input voltage V in plus minus V in minus. An operational amplifier consists of three elements. Ri is the input resistor, Ro is the output resistor, and AVOPVI is the voltage-controlled voltage source. AVOP is the voltage gain of the op-amp. According to the data sheet of the TL082CP, the typical values of these elements are, Ri equals 10 to the power of 12 ohms, and AVOP equals 2 times 10 to the power of 5. Although Ro is not available from the data sheet, it is several hundred ohms. This example shows that Ri is very large, Ro is small, and AVOP is very large. So, an ideal operational amplifier is represented by this equivalent circuit, where the input resistor is removed, the output resistor is short-circuited, and the voltage gain AVOP is infinite. This is the equivalent circuit of an inverting amplifier. You can start the analysis of this op-amp amplifier with Vi equals 0. Since AVOP equals infinite, Vi should be 0 to keep V2 within a finite value. This circuit works to keep Vi at 0. This is called a virtual short. Without any direct connection between the two terminals, there is no voltage difference. They are virtually short-circuited. Due to the virtual short, node A is at the ground voltage. Thus, according to Ohm's law, I1 equals V1 over R1. The input resistance Ri is infinite. So, no current flows from node A into the op-amp. Thus, I2 equals I1. Then the voltage drop across R2, VR2 equals R2I2, and it is expressed as R2 over R1 times V1. The output voltage V2 equals negative VR2 minus Vi, and it is derived as negative R2 over R1 times V1. The voltage gain AV is given as negative R2 over R1. The negative sign means that the polarity of V2 is inverted from that of V1. The key point of this gain is that AV is determined by the external resistors. No Q point setting is needed, making the design of the voltage gain easy. Furthermore, if R1 and R2 have the same temperature characteristics, AV is robust to temperature changes. If R1 equals 1 kilo ohms, and R2 equals 10 kilo ohms, then AV equals 10. If R1 and R2 are 1 kilo ohms, then AV equals 1. The values in experiment 11.1 matched well with these theoretical values. Exercise 11.1. This is your homework. Pause the video and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.